Hello everyone, welcome back to my YouTube channel. Today we are going to create credit card fraud detection system using logistic regression in Python, and we'll cover the complete machine learning workflow from understanding imbalanced datasheet till the time we detect the fraud. By the end of this tutorial, you will know everything that how to build the model. Also, you will understand that how this works in the practical scenario. So let's move. So first of all, let me show you the data, and in data, you will notice that the name of the variable are v1, v2, and I have kept them like this because I don't want it that the real bank data, because this I downloaded from Kaggle and it was a real bank data, and I don't want it to disclose a real bank data which is from a German bank. Now the thing is, the variable name does not matter. The reason is because all these variable would be tested on different statistical measures, and you don't need to worry about the variable name because we would be eliminating the variable on the basis of those statistical techniques, because we will check each variable on the basis of that parameter. If this will be within that range of that particular parameter, then only we will be proceeding. Now this fraud detection model is going to actually change your way of thinking because this is a real time data, you can see, right? And it's not a small data, so you can download this from the GitHub repository. The link will be there in my description of this video, but make sure that you download this properly. Now let's go to the code. Actually, this is the main bread and butter of this video. In this video, we would be using logistic regression, which is one of the most popular classification algorithm. And along the way, we will also build a proper machine learning pipeline, avoid data leakage or any kind of situation. Okay. So first of all, let's begin by importing all the required Python library. That is the step number one whenever you are going to build any model. Here we are importing pandas, numpy at the top, and then you can see the whole module is talking about Scikit-learn. That is very important library. Okay. Scikit-learn module is for processing, model building, cross validation and evaluation. Everything will be done by the help of Scikit-learn. Okay, now just remember that I am importing the whole package for the train, test, split, everything. We would be checking ROC-AUC, which talks about the accuracy of the model. Then we'll be talking about F1 score and other matrices, precision, recall, everything. Now on the basis of this only, your model is considered good if this is under those values which are required for this model. Just remember, so that's where your step number one is. You are just importing all the important module, and having all these library imported at the beginning basically keeps our workflow clean and organized in the real world scenario. So always follow this. Okay, now step number two. Here what I'm doing, I'm loading the data set. Now let's load our data set. Okay, I just ran this code, that's why you can see the output already, but I will run it for you guys again so that there is no discrepancy you will see. So let's run, let's assign these library. I just clicked on shift and enter and it has ran. Okay, if there would have been any error, it would shown here. Now let's run this second cell. It's running in the backend. Now it's ran quickly. Okay, so we are using the famous credit card fraud detection dataset. As I said, after loading the CSV into pandas data frame, we basically prints its shape. The shapes tells us two important things: how many transactions are present and how many features each transaction is containing. Finally, I'm just using the head function. What head function would be doing? Head function will be showing the top 5 rows, and that's what it does. Okay, so this is quickly to understand the structure of our data, and that's what the plan is, so that we should, as a data analyst, should have that understanding that how we are going to reshape this data. You can see also that it has shown only 5 row, so head by default shows the 5 row and all the columns which are present in your data. Now next step is step number 3, target imbalance check. So what does that mean? Before building any machine learning model, it's always important to understand the target variable. Okay, here we are checking the percentage distribution of the class column which was there in the data. If you see at the last, it was there. Okay, in the data you will see that class is having 0 and 1 value. Class 0 represents legitimate transactions, while the class 1 represent the fraudulent transactions. That's what the parameter is and the flag. As expected, we can clearly see that data set which I have already shown to you. Let me again open it so that things are totally clear. So as I said, that class 0 represents the legitimate transaction, class 1 represent the fraudulent, and in this model that is our end goal, that we should be able to detect the fraud. Okay, so now in this particular file you will see almost all transactions are genuine, while only a tiny percentage of the transactions are fraudulent transactions. This is the data generated by the data team at the backend. As a model developer, all you have to do is to basically understand the data correctly. Sometime this data will not come from a single source, so you need to make sure. Okay, now this is the class variable. Let me zoom it a little bit and let's go a little down on this one. You will see some lesser number of transaction is having 1. So let me maybe apply the filter showing disable. For me, I don't know, some issue, but let me do Control F and we can search for 1. So you can see 1 value is here. At the row number, the row number is going to be 543. Then again you have at 625, then you have at 4000, right? So there are flags. These are the flag. That 1 itself is considered as a flag. You can see this one, right? So this one is a flag that there are transactions which are fraudulent. Now coming back to the code we have. So almost all transactions were genuine. This imbalance makes fraudulent detection much more challenging sometimes, because there are very less fraudulent transactions are happening. Okay, because accuracy alone can become misleading sometime. Just remember that. Okay, that's why later we will focus on precision recall, all these things. So I was doing F1, ROC-AUC curve, PRAUC instead of relying only on the accuracy. Accuracy sometimes can overkill the things. That's what I am trying to achieve here simply. Okay, now this was the breakup. Basically these were the legitimate in that data set which I prepared, and only 0.17% was the fraudulent. Now what is the next step here? So the next step is basically data cleaning here. Okay, guys, just remember one thing, it's not always necessary that we would be doing the complete EDA. Don't think that why we not checking missing dates, missing value. It depends on the data. Okay, in this data we have certain rules, so I am proceeding on the basis of those rules. Now we are performing some basic data cleaning. First we will inspect the data information using the info, and this helps basically identify data type and missing value. Next we will remove the duplicate transactions. You can see at your screen, and duplicate record can be bias the learning process, because the model may repeatedly actually learn the same information again and again, which is going to be redundant. Finally, we print new shape of the data to verify how many duplicates rows were removed. So that's what I'm trying to do in the print statement. Let me run this piece of code. Again, I'll click anywhere, then shift and enter. So you can see this. It's pretty clear. Okay, we are able to print new shape of the data. Shape after dropping duplicates, this is the shape of the data. That means number of rows are this and number of columns are these. Okay, so now let's move forward. Step number 5, which talks about a feature and target separation. This is again going to be very important. We are doing that on the basis of the flag variable, which is going to be class, and on the basis of class we will segregate these features and target. Features are also known as input variables. Okay, so don't get confused. Now basically in this step, it's time to separate the independent variable from the target variable. All columns expect the class become our feature, which is known as x-axis variable, and the class column becomes our target variable, which is the y-axis. Okay, this separation is a standard practice before basically training any supervised machine learning model. That's what I am doing here. Let me quickly run this. This has been successfully ran on the backend. Now you see the effect of this. In the next cell, if you see what I'm doing, it's the main thing, which is splitting your data. Splitting is again very important. Why? Because we split our data into training and test. Notice something very important here, that we perform the train and test split before any pre-processing. This is done completely to avoid data leakages. We don't want any data to get leaked here. Now, if pre-processing is done before splitting the data, information from the test can unintentionally leak during the training process and resulting in sometimes unrealistic high performance issues. We also use stratify equals y, since our database, this data set is highly imbalanced. Since our data set is highly imbalanced, so basically stratified splitting ensure that both the training and test data sets preserve the same fraud to normal transaction ratio, which you can see here. This is a very simple coding method I have used in this particular project for all of you. Let's see the output. I just ran the code. So training shape was this much, test was this much. If you see the percentage, you will be able to understand. Now train fraudulent rate is this much and test fraudulent rate is this much. That is also you have received on the basis of all the functions you defined up there. Now remember guys, we are taking the mean on the basis of the Scikit-learn library. Up there we are checking all these things. Now let's move to the next part. We have done the split of the data. Next is basically separating the PCA and non-PCA feature. Now there are so many variables, as I said in the starting, which are already PCA transformed. Like I'm not giving you any personal information what that individual column talks about. There are cases when you have those information, well and good. There are cases when you don't have the column name. You just have to understand the statistical measures. Check the interval, whether those variables are falling in those interval or not, and you have to take a call. Now in this step, what we are doing, interesting aspect of this data set is that the feature V1 through V8 are already transformed into a PCA compliant data. This is a principal component analysis. What does that mean? These PCA features are already standardized. However, the time and amounts are not. You could see that in the last, right? So those are not standardized. Therefore, we separate them. Later, we will again pre-process only these two columns instead of unnecessarily transforming all the PCA features. I hope this makes sense. The reason is this approach keeps pre-processing efficient while preserving the original feature distribution, and your data seems to be good on that. Now let's run this. Move forward. This has also run successfully. Guys, also if you want to print each and every step, you can use the print function, and so that you can get to know that at every step on the back end also how things are processing. Now in the step number 8, it is one of the very important step, considering you are doing so many things are here, because we are only transforming the PCA features, which are the unnamed variable. So what we are doing here, we are performing diagnostic analysis on the PCA transformed feature. For every PCA feature, basically what we will do, we will calculate missing value, mean, median, standard deviation, skewness. This gives us the statistical summary of the dataset and helps verify whether additional pre-processing is required on the PCA variable or not. Since PCA feature are already normalized, as I said, in the database, in the dataset which I was using, they generally require minimal processing. So what I'm doing here, you can see that all these aspects I am trying to achieve. Okay. Now just creating a data frame using the whole and soul. Now summary would be no missing, infinite value, already standardized, so no further pre-processing, as this is a kind of a medium level of the project. Okay, but this is to give you a very good idea that how actually fraudulent transactions are processed and detected. Now you see, once I ran this, you can see for each variable, each feature in your model, you have missing values, variance, standard deviation, and infinite value. All of that you have got here. Now next step is to diagnose analysis for the time and amount. Those are the two different variable we extracted them, right? Now what is the meaning of this? Why we are doing this? We analyze the two no-PCA feature of our model. The reason is we calculate quartiles and identify potential outliers using the interquartile ranges or IQR methods here. What are the interquartile ranges? There are, like in the year, right? There are 4 quarters, Q1, Q2, Q3, Q4. So similarly, we create quartiles here, like up to 0.25% putting in a single quartile. Then from 0.25 to 0.50 would be the second. The third is up to 0.75. Okay. So here we calculate quartile as I said. Outliers can significantly influence machine learning model. Again, remember that instead of removing the complete thing here, we will basically what we'll do, we'll clip external value during the pre-processing. This allow us to reduce their impact without losing the valuable information. Now let's run this. I hope on coding level, if you have any doubt, let me know, because this is a kind of a project. Okay, so we are not going by programming perspective. We have to learn Python. We are building a complete project. Now you see that we have got the skewness, outlier, missing value, and standard deviation for these non-PCA variable. Now one thing to remember and to recall, for the PCA variable we checked the variance, standard deviation, range, and other aspects. Here we are checking skewness also. Remember this, it's important. Sometimes they ask in interview. Now next step is basically, here we are creating a customer transformer called IDQ Clipper. Okay, this transformer basically follow the fit and transform structure required by the Scikit-learn pipelines. During training, it calculates the lower and upper IQR bounds, and during transformation, any value outside these limits which are given here, this is basically clipped, those limits which I said. Now this approach is much safer than deleting observation because it preserves the size of the data set while reducing the influence of the external value at the same time. Okay, now let's run this. Successfully executed. Now next step is build pre-processing the pipeline. Now we are constructing the pipeline. Only the time and amount feature go through the pre-processing. Inside the pipeline, we transform missing value imputations, number 1, outlier clipping, and standard scaling, while the PCA feature bypass pre-processing because they were already standardized. Okay. Finally, we combine both these column transformers and which create a clean and reusable pre-processing workflow. Let's run this. Successfully executed. Now next step, very easy one. We basically combine pre-processing and logistic regression into one complete pipeline. This is considered as the best approach actually generally in machine learning. That's what I have seen in my experience. And the biggest advantage is that every pre-processing step is applied through consistency during the train and prediction. It's also completely to eliminate the risk of the accidental data leakage. Nothing else, simple thing. Next step is step number 13. What I am doing? Hyperparameter checking. Now hyperparameter grid is something I am checking. Okay. Instead of using the default logistic regression model settings, we are defining multiple hyperparameter combination. Here we are basically tuning parameters like the regularized strength C, you can see the penalty type and the optimization solver. So this basically helps us test multiple combination and helps to find the configuration also that produce the best performance for us, for our model. Let's run this. Step number 4, simply stratified cross validation. Now we defined the stratified k-fold cross validation, and the data set is divided into 5 folds. During the training, model is basically trained on 4 folds and validated on the remaining 4. Okay. This process repeat 5 times. Using stratified sampling ensure that every fold maintains the same fraudulent to normal transaction ratio, which basically leads to much more reliable performance and the estimation. That's why we do this step. Let's run this. Hyperparameter tuning. Again, a very complex one. Sounds like, right? Not. Simple, everything is simple. Just focus. Now, this step is, it comes on the one of the most important phase of the model building. And basically to get that fraudulent notification, we are using the GridSearchCV to test every possible hyperparameter combination instead of optimizing for just accuracy. You can see here we are creating that. We are not just checking the accuracy of the model, because instead of optimizing for accuracy, we are optimizing average precision, also known as PRAUC. Okay, remember this, again an interview question. But why we are doing this? Why? This is again question, right? Somebody can ask you why you did that. Because PRAUC performs much better on the higher imbalanced data set like fraud detection. After grid search finish, we obtain the best performing logistic regression model. That's the whole role of this part. Let's run this. You can see the output. As I said, fitting 5-fold for each 4 candidates. Okay, this is clear. Now next step is step number 16. This is basically optimization model is ready. Okay, now you can see that the model is ready. We use this to make prediction on the completely unseen test data, which we have not used as of now. The model generate 2 outputs here. First is to predict the class, whether a transaction is fraudulent or genuine. You can see. And the other one, the second one basically is for what? These are for probability score. Okay. That will actually later help us to evaluate ROC or precision recall curve. That's why we are doing this. Let's run this. Now we will evaluate our model in the next step. This is again from model validation perspective, fraudulent transactions identification validation perspective will come here. Now it's time to evaluate. We basically calculate several performance matrices: accuracy, precision, recall, F1 score, ROC. Every metrics here itself is a full concept. If you want to understand that, you can Google or you can basically check on my channel itself. I do have a dedicated video for all of them. Now, since fraudulent detection is an imbalanced classification problem, okay, so recall becomes especially important. A high recall means that the model successfully identify most fraudulent transactions, reducing financial risk. And as I have already displayed the confusion matrix and classification report to understand exactly how many fraudulence were correctly detected and how many were already missed. This is important concept, guys. Don't miss any of these lines which I'm actually telling you. Now let's run this. You can see all those value you have recovered. Now you need to understand the value computation. What are the matrices in your bank, in your company they are using. Now just to simply interpret this, this is the ultimate goal we have. Okay, just for the interpretation, what is the meaning of all this value which we have got? Our model achieves a strong recall, means if you see, what is the meaning of this? It successfully catches the majority of the fraudulent transactions. Recall is the most important metrics here. Although there are some false value, this trade-off is generally acceptable in banking system because it's safer to investigate a suspicious transaction than for the missing actual frauds. So that is again a very important aspect of this. This whole project actually follows industry best practice for using pre-processing pipeline, avoiding data leakages, employee stratified cross-validation, and optimize hyperparameter using the grid search. This technique make the workflow reliable, reproductionable, and production ready. It's very important on that aspects. Now, that's how we build a complete credit risk fraudulent detection system using the logistic regression model. This is the whole code, which you also get a link on my description. In this project, we covered data cleaning, pre-processing, feature engineering, machine learning pipeline, hyperparameter tuning, and a detailed model evaluation. Everything was from the eagle eye perspective to give you the concept. If you guys like this video, I will make a detailed video for each step, because that video will be around 2 to 3 hours of the length. So if you found this project helpful, don't forget to like the video, subscribe to my channel, and share it with the machine learning enthusiast. And thank you for watching. I will see you all in the next project. Make sure you download the code and the input from my GitHub repository. Both the links will be in the description. Thank you so much. All the best.